Next, we are going to study about the types of liquid solutions. There are two types of liquid solutions. One is ideal and second one is non-ideal solutions. So this is based on, this classification is based on Raoult's law again. Here, today we are going to discuss about ideal solutions. What are ideal solutions? So ideal solutions are the solutions which obey Raoult's law or the entire range of concentration. Or entire range of concentration means concentrated to dilute, very dilute solutions. If they obey Raoult's law, so then they are known as ideal solutions. Solutions which obey Raoult's law are known as ideal solutions. This is very important, the point of your examination, theory examination. So now, what are the characteristics of ideal solutions? So the first characteristic, these ideal solutions are characterized by these things. The first one is enthalpy of mixing. Enthalpy of mixing is equal to 0. Means when you mix two components of solution, for example, if you take component A and component B, you are going to mix these two components. When you mix these two components, no heat is absorbed or evolved. The absorption of heat or evolution of heat depends upon the type or the strength of intermolecular forces. Here no heat is evolved or no heat is absorbed. The enthalpy of mixing is equal to 0 for all ideal solutions. Next, the volume of mixing, delta V mix, the volume of mixing is also equal to 0. That means the volume of the solution is not going to change after mixing the components. When you mix two liquid components, for example, volume of solution is equal to the sum of the volume of two components in the solution. Sum of the volume of two components. I will give you the example. You take component A and B, 10 ml of A and 10 ml of B. If you mix these two, the volume of solution is equal to 20 ml. This is true for ideal solutions. In some other solutions which are called as non-ideal solution, this volume is not always equal to 20 ml. It may be equal to 19.9 ml or 20.1 ml. So this is also possible. But for ideal solutions, the volume of mixing is equal to 0. There is no change in volume upon mixing. The total volume of the solution is always equal to sum of the volume of the two components present in the solution. So that is why volume of mixing is also equal to 0 for ideal solutions. The next one, in terms of intermolecular force of attractions, how do you explain these ideal solutions? Again, you take that two components A and B. If you take component A and B, in component A, there is an intermolecular force of attraction between the molecules of A. Intermolecular attractive forces are present between the molecules of A, which is termed as AA. Similarly, in component B, there is an intermolecular force of attractions, intermolecular attractive forces. They are known as BB type of attractive forces. Next, you mix these two components A and B. When you mix these two components A and B, you will get a solution. So what happens when you mix these two components? What happens when you mix these two components? Component A starts interacting with component B. Component B starts interacting with component A. And they try to break their interactions. Okay, molecules of A tries to break the interactions between B. Molecules of B tries to break the interaction between A and they get separated. The intermolecular force of attraction between these two decreases and they get separated, AA and BB. Now in the solution, a new force is developed or new intermolecular attractive force is developed, that is AB type of attractive force. Now for all ideal solutions, for every ideal solution, interactions AA, BB and AB interactions are same. Okay, that means intermolecular attractive force between AA, intermolecular attractive forces between BB and intermolecular force of attraction between AB are all same. That's why there is no heat is absorbed or evolved. So this is about the characteristics of ideal solutions. So what are ideal solutions? Solutions which obey Raoult's law or entire range of concentration. What are the characteristics? enthalpy of mixing is equal to 0. There is no heat absorption or no heat is evolved. What is volume of mixing? The volume of mixing is also equal to 0. There is no change in volume upon mixing. The total volume of the solution is equal to sum of the volume of two components. I will give you the example. I have already given. The same example I will explain. If you take 10 ml of A and 10 ml of B, after mixing you have to get 20 ml of the solution, not 19.9 or 20.1 ml. Next, in terms of intermolecular attractive forces, how do you explain this? In terms of intermolecular attractive forces, if you take two components A and B, in component A we have AA type of interaction, in component B we have BB type of interaction. When you mix these two, what happens? They start interacting with one another. Molecules of A breaks, the interactions between B, molecules of B breaks, the interactions between A. Now a new interactive force is developed, intermolecular attractive force is developed, that is AB. For all ideal solutions, AA, BB, AB interactions are same. Next, examples. We have some examples here. Practically, no perfect ideal solutions are present, but somewhat they obey Raoult's law. So in that, first example is mixture of N-hexane and N-heptane. Second example, mixture of bromoethane and chloroethane. Last one is benzene and toluene. Here, in N-hexane, intermolecular force of attraction between N-hexane, intermolecular force of attraction between N-heptane, and between N-hexane and N-heptane are all same. That's why they behave like ideal solutions. In these two examples also, you can explain the ideal behavior based on intermolecular attractive forces. Okay, this is about ideal solution.